Say cheese. Did you actually say cheese? Because that'd be pretty funny. Um, we're going to continue our lesson on linear functions today. And we're going to go through this last page of notes, which is a lot of practice with what we've been dealing with, a little bit of application as well. So let's start with number 9. It says, the cost of a school photo package includes $40 for the photo shoot, plus the number of photos ordered multiplied by the number, or by the price per photo. Is this situation defined by a linear function? Predict the answer and then write and graph an equation on another sheet of paper to check your prediction. You can use 250 or any other value as the cost per photo. So let's just stick with that 250 per photo. So it says essentially you have to pay $40 for this photo shoot plus 250 per photo. Do you think that's linear or not? Well, does it have a constant rate of change and maybe an initial value? Well, of course it does. Our rate of change is 250 per person. There's our rate of change. And we have an initial value of 40 because no matter what, you got to pay $40. So there's our initial value. So you don't have to go any further to tell that it's going to be linear. We can even write an equation that we say the cost is equal to $40 plus, what is it, 250 per photo? Let's say 250p. And that's a linear equation. There's no exponents, there's no square roots. It is a linear equation. Now, one more thing, two more things you could do to check it is, one, you could make a t-chart. Start finding picking some x, y's. The photos have to be, you can't have negative numbers for photos. So you can do 0, 1, 2, and just see what happens. When you plug in 0, you do get 40. You plug in 1, you get, this is going to be p and c instead of x and y. But 4250. The next one would be 45. So you'll notice that every time you go up one photo, you are going up by 250. So it is linear. You could also graph it, and it'll graph a straight line. We're going to cross out the graphing part because we're not going to do that right now. Let's go to number 10. All right, number 10, it says, read 2 students' answers to a math problem. All right, we've got Emma. She says, y equals 10 minus 2x is not linear function because the graph has a negative rate of change. And there's a graph right there. Georgia says y equals 10 minus 2x is a linear function because it can be written in the form y equals mx plus b. So what she does is she took the original equation here, and she just changed it to a plus, which you can do. It's just plus a negative then. So 10 minus 2x is the same thing as 10 plus negative 2x. And then the commutative property says you can change the order of addition, so it's negative 2x plus 10. And yeah, that is in y equals mx plus b form. So really both girls set something up to show that it is, in fact, linear. This one is a graph, and it's a straight line, so yeah, it's linear. This one is an equation in y equals mx plus b form, so again, yeah, it's linear. But Emma's final answer and reasoning wasn't quite there. Just because it has a negative rate of change doesn't mean it's not linear. It's just a line going downward. So Georgia is correct. It is linear. And you can look at the graph or you can look at the equation. Let's go down to the last one on this page. It says, write an equation that is not a linear function. Justify your answer. So why don't you pause it for a second. Pause. Come up with an nonlinear equation. All right, you can come up with anything that has to do with an exponent. So you can say y equals x squared. You can say y equals 2x cubed. You could say y equals x squared minus 4. You could say something that has a square root in it, like y equals the square root of x. You could even do one that's like y equals 1 divided by x. As long as it's not in the form y equals mx plus b, or can't move into the form y equals mx plus b, or y equals mx, then it's not linear. And again, all of these, if you graph them, you'd see that they're not linear. They're going to make anything other than a straight line. All right, let's go on to the second page, number 12. Use what you have learned to complete this task. It says graph each pair of functions on the same grid using the x values 0, 1, 2, 3, 4. And the reason there's no negative x values is because the graph doesn't have negatives on here. So I'm going to do function A for you, and I'm going to have you do function B on your own. So for function A, we've got y equals x plus 1. So I've got my x's and my y's. 0, 1, 2, 3, 4. So if I'm going to plug in to find this, for 0, I'm going to do y equals 0 plus 1. 0 plus 1 is 1. If I'm going to plug in 1, I'm going to do y equals 1 plus 1. 1 plus 1 is 2. If I'm going to do 3 or 2, I'm going to do y equals 2 plus 1. 2 plus 1 is 3. And you can probably figure out this is going to be 4, this is going to be 5. It's just adding 1 to the x value. Okay? And I'm going to actually graph that right now. I'm going to say I got 0, 1, 0 over, 1 up. Remember, elevator, you go over or in first, and then you go up or down. First number is left or right, second number is up or down. So the x, we got 1 and 2, so 1 over, 2 up. And then we got 2, 3, 3, 4, 4, 5. So that, my friends, graphs a line. Now I'm going to do the second one, and I'm going to make a t-chart again with an x and a y column. And it says to pick these values, 0, 1, 2, 3, 4. So to find the first one, I'm going to take 0 and plug it in right here. Plug it in, plug it in. So I get y equals 2 times 0 plus 1. 2 times 0, 0 plus 1 is 1. Second one, I've got y equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 I get 3. 2 times 2 would be 4, plus 1 would be 5. And you can maybe see the pattern. I'd get 7, and I'd get 9. So it is a constant rate of change. It's always going up by 2 on the y's over 1 on the x's. Let's plot some points. So I've got 0, 1 is my first point. Ooh, it matches up. 1, 3. 1 over, 3 up. 2, 5. 3, 7. 4, 9. So you'll notice they actually start at the same place. They have the same initial value. However, they have different slopes, so they go up at a different rate. So let's answer the questions below for this one. It says, answer the questions for function pair A. Are the functions linear or nonlinear? Well, you can look at the equation. They're in y equals mx plus b. You can look at the graph. They're definitely straight lines. So they are both linear. Do the functions have the same or different rates of change and initial values? Oh, so we just said that. Different rates of change, because one of them has 1 and one of them has 2. So different rates of change. But they have the same initial value. They both start at 1. All right, number 3. How can you describe the graphs of other pairs of linear functions with the same similarities and differences in rates of change and initial values? Well, if they're going to have the same rates of change, it has to be 0 or 1, so they're going to go up the same amount, and where they start will depend on what the initial value is. Not the best question worded, but you can definitely explain that. Different graphs that would have same rates of change or different rates of change. But what I'd like you to do now on your own is function pair B. So this is you. I'd like you to pause it, set those two up, and then answer the questions below for part B. Alrighty, so I did those in purple and blue again. The first equation is in blue. There's my table of values, a little bit of work there, and then the graph. And the second one is in purple, my table of values and a little bit of work. So are these two linear or nonlinear? Again, we're just answering these same questions for pair B. And you can do it below because there's space for that. So number one, it says, are they linear or nonlinear? Well, they both definitely are linear. They graph a line. Number two, do the functions have the same or different rates of change? Rates of change in this case would be 1 and 1. So they do have the same rate of change. So same rate of change. But they started at a different point. One started at 4 and one started at 3. So we have 3 and 4 as our initial values. So we have different initial values. So number three, how can you describe graphs of other pairs of linear functions that have similarities and differences in rates of change? So this time we have the same rate of change. And what do you notice about these lines? They don't ever cross. So same rate of change or slope might be parallel lines. That is something interesting here. As long as they have the same rate of change, they go up by the same amount, they'd be parallel. So that's what we want to talk about today, comparing some different things with linear functions and taking our linear functions and graphing them so we can compare them. And that goes all the way back to what our overarching goal for this unit, this week is, this section, lesson 8, is to be able to determine if things are linear or nonlinear, and use the equation y equals mx plus b and compare things that are linear and nonlinear. So that's all I've got for you for today. We'll talk to you later.